Today, I'll be making soap from bacon and drain cleaner. First step is going to be to cook all the bacon and extract the grease. As you can see here, I got some of the fattest bacon I could find so that we could get as much grease as possible. So after cooking all the bacon, we have 156 grams of bacon grease minus the 18 gram weight of the container is 138 grams of grease. Interesting sidebar, there are about 7 servings per container and total fat per serving is 8 grams. 8 times 7 is 56, yet I yielded 138 grams, not 56 grams of grease and fat from this bacon, so maybe that's a story for another day. I just thought it was worth mentioning. Now, this isn't a video about false advertising. This is a video about chemistry, so let's get back to making soap. Now, I could have actually probably gotten some more grease out of this bacon. As you can see, it's not burnt or anything. And considering the fat content, I think I cooked it pretty well. But before we move on to the step involving drain cleaner, there is something really important that needs to get taken care of. Yeah, you've been smelling it the whole time I've been cooking it, huh? Here you go, puppies. All right, now before anyone accuses me of animal endangerment, you two do not need to be in the kitchen during an exothermic chemical reaction. So, outside. Bye-bye, puppies. So the next step in this process involves mixing lye, or sodium hydroxide, in water to create an alkaline solution. So, for the purposes of making soap, hold on a second, I'm out of beer. So for the purposes of making our soap, we need roughly 13% of the bacon grease weight in sodium hydroxide. And we need roughly 30% of the bacon grease weight in water. And we're going to add the lye slowly and mix it around until it is fully dissolved. Now, of course, this is only going to work if both are liquid. So the bacon grease, while still liquid, is going to cool pretty rapidly and start to solidify. Luckily, the combination of lye with water, when you drop this in there, is an exothermic reaction. So even if I'm using lukewarm distilled water to make this solution, it's going to heat itself up to an appropriate level that we can mix it with the bacon grease without causing any issues. The bacon grease, though, we may have to warm up in order to match the temperature of the sodium hydroxide alkaline solution after mixing. But we can talk more about that. Let's actually just get started mixing those two chemicals. So based on 13% of the total weight of the bacon grease, I have roughly 18 grams of sodium hydroxide in this bowl, accounting for the weight of the bowl, obviously, on the scale, which is 154 grams. Excuse me, 152 grams. We've measured out 44 milliliters of distilled or filtered water. So now we're going to slowly add the sodium hydroxide into the water, stirring thoroughly as we move it. Now, both of these should be roughly 100 degrees Fahrenheit, so the time is of the essence, really, to make sure that we mix these and get the temperatures just about right. I'll be doing this under a vent fan just in case there's any fumes and stuff, so please, sorry about the noise. So like I said, this is an exothermic reaction, meaning as the sodium hydroxide dissolves into the water, it is producing heat. The heat that it's producing should be enough to bring it up to the temperature to mix with the bacon grease, which is It's 99 degrees right now, so it'll still work. I just got to make sure I get it in there quick. But first, I'm going to use that thermometer to make sure that this solution isn't too hot before I put it in there. See how hot this is? Ooh. 103, 107, 111, it's climbing. 124, 126, 7. Past 130 now, so we're just gonna let that sit for a little while. 144, 45. Where are my stacky things? Here we go. This is recording, right? Okay. It'd be terrible if it wasn't. Okay, so we just passed 150 degrees on that solution, so I am going to heat up the bacon grease in the oven while this cools down. So while I'm waiting for these two temperatures to equalize, I think it's a good chance to talk about a little bit of the basic chemistry that's going on here. So when you add sodium hydroxide, a base, to water and you create a solution, it is an alkaline solution. Now with the bacon grease, that is full of lipids, fatty acids. What happens when you mix an alkaline solution with these fatty acids is it undergoes a process called saponification, which kind of sounds like soap. So what ends up happening is when this alkaline solution with the sodium hydroxide mixes, well, it's no longer sodium hydroxide after being dissolved, but when it mixes with those fatty acids, it creates a ton of molecules that have a polar end and a non-polar end. So the thing that makes it soap is that all of that dirt and grease and grime on your body is mostly non-polar. Whether it's mud or bacteria, it's not a polar molecule or nothing. It's not polar. So what happens is these soap molecules, they have one end that is polar, that is hydrophilic, meaning it's attracted to water. The other end is non-polar, it is hydrophobic, and it will attach to any of that dirt, grease, grime, yucky crap on your skin. What ends up happening with the soap is it will attach one end to the dirt or what have you, then the other end of the soap, the polar end, attaches to water molecules that you are running your hands under the water. The oven just started. And that's the basic process of how soap works. Is it's basically like a rope that sticks to the dirt and it sticks to the water and it pulls it away from your body. So that's what we'll be making here. Real quick side note on the saponification process is soap makers have a term that they use called superfat. And basically what superfat means is that there are going to be leftover fatty acids inside of your soap that did not create soap molecules because there wasn't enough alkali in your solution. So the reason for this is you ever see like moisturizing soaps. They are not perfectly saponified. There was, in the process, the ratio of grease to alkali was slightly skewed to leave fat left over in the resultant soap. What this does is instead of creating a soap that strips all of the oils, the natural oils, away from your skin alongside those foreign particulate, the dirt or what have you, they leave a little bit of fat in there to maintain some oil on your skin after you use the soap. So here, when I was going through the process of measuring out the amount of sodium hydroxide I put in the water, it was really like 19 grams. I went slightly less so that you ever get that squeaky clean feeling with like the super cheap $1 soaps? That's because they don't have super fat. All of their fatty acids, when the soap is being made, were saponified, so you don't have any oils left over on your skin when you're done. That draggy feeling, it's not good. So ideally, once this is done, there will be enough fat left over in the bacon soap where I'll get a nice like bacony scent on my hands or my body after I use it. Alright, so alkali solution is at 122 and dropping. My ideal range here is 100 to 120, so I finished the bacon, by the way. It was delicious. I'm going to pull the grease out of the oven and see if I brought it back up into the ideal range. I might have gone a little high. I set the oven to its lowest setting, 170, and then forgot it was in there. So, take this out and rinse it off. And try to equalize these temperatures. A little too hot. All right, so bacon grease has dropped to 123, and the sodium hydroxide solution, the alkaline solution, is reading a little over 110. So I figure if my ideal range is 100 to 120, then the act of pouring this bacon grease into the final mold. Sorry, love, I'm using one of your Pyrex containers. Hope my wife doesn't kill me. The act of pouring it in there is bound to cool it down below that threshold of 120, and we can start mixing the two solutions. Yeah, that fits. God damn it. Ooh, that's thick. Ooh. The next step, once I'm done thoroughly and vigorously mixing this solution, is to stick it in the fridge for 24 to 48 hours and then just come back, check on it, and see how it turned out. So I believe I've mixed it as well as I can, so I am going to put it in the fridge and, whoa, stuck to the oven there. I'm going to put it in the fridge and check on it, I guess, tomorrow night. All right, so here is the soap that was made using the bacon grease and the sodium hydroxide. I left it in the fridge for a while so it would harden a little bit more, and then I took it out to cure for another 12 hours. Now, typically, when you make a soap like this, you want to let it cure for like 4 to 6 weeks, just so that it dries and you can cut it into kind of like a bar shape. While it's curing, the saponification process slowly continues. And part of the reason why you wait a long time is because if there is any excess sodium hydroxide in there, it can be very caustic and it can be irritating to your skin. However, I want to get this video made, so I'm going to be using it a little bit early. Right now, it is not hard enough to be cut into a bar. It's more like the soap that comes out of your dispenser. It's a little softer. So what I just did is I went outside and I rubbed my hands in the dirt, and we're going to see how this soap works. Washing my hands with it. See how it goes. Bacon soap. Now, not only are my hands clean as a whistle, but they smell great. Thank you very much.